Have you ever looked up at the night sky and just felt this sense of permanence, like it's all eternal? Well, today we're going on a journey to the very end of time itself to see how that brilliant, seemingly endless cosmos is one day going to fade to black. Let's dive in. This idea is so powerful because it doesn't just apply to us. It applies to everything: the stars, the galaxies, the entire universe. The very atoms that make you up right now were forged in the hearts of stars that lived and died billions of years ago. This whole cycle of creation and destruction, it's the engine of the cosmos. But here's the thing about cycles. Even this one eventually has to end. All right, so let's start with the universe we actually know. We live in this absolutely brilliant, dazzling era of light, which cosmologists have a great name for: the Stelliferous Era. This is the age that makes everything we know and love possible. The light we see, the stuff that makes up our planets, our bodies, it's all a product of stars living, burning, and eventually dying. But here's the real crisis in our perception. We make the mistake of thinking this bright, vibrant phase is just normal, that it's the way things have always been and always will be. But it's not. It's just a temporary moment. A really great way to think about it is like a campfire. Right now, it's roaring, it's bright, it's throwing off all this light and heat, but that fire is actively burning through its fuel. And in the universe's case, that fuel is hydrogen gas. And just like any campfire, eventually the fuel is going to run out. And this just perfectly illustrates how short-lived our era really is. I mean, look at this timeline. Our Stelliferous Era is just one little chapter in a much, much longer story. It came right after that chaotic primordial era. And what comes next? Well, that's where things get really dark. To really wrap our heads around the end of the universe, let's first bring it right back home and take a look at the fate of our own star system. Now, this isn't some maybe. It's not a theory. It's an absolute inevitability. For billions and billions of years, our sun has been smashing hydrogen atoms together to make helium. But that supply isn't endless. And when that main fuel tank finally runs dry, a really dramatic transformation is going to begin. The sun's core is going to collapse, and that's going to trigger one final furious burst of energy. Its outer layers will swell up, completely swallowing Mercury and Venus. And here on Earth, the heat will become just unbearable. Our oceans will literally boil off into space, and our planet will be sterilized, a scorched, barren rock. So after that whole red giant phase, all that will be left of our magnificent sun is this: a white dwarf. It's basically a smoldering Earth-sized ember. It's unbelievably dense, and it'll just be faintly glowing in the dark. It's the cosmic ghost of the star that once gave us all life. Now, what happens to our sun is pretty much a preview of what's going to happen to every single star in the universe. So, as we zoom out from our little solar system, we enter a brand new, very dark age. 100 trillion years from now, just try to let that number sink in. By then, the universe will have completely run out of the free-floating gas it needs to make new stars. The last, lonely red dwarf star will burn through its last bit of fuel and then flicker out. And with that, the universe is plunged into a profound, unending darkness. The age of light is officially over. So, welcome to the Degenerate Era. The universe is now basically a cosmic graveyard. It's this vast, cold, empty space, and it's punctuated only by the stellar corpses left behind: the white dwarfs, the neutron stars, and of course, the ultimate cosmic monsters, black holes. Okay, so here's the really mind-blowing part. Even these dead stars, even these black holes, they aren't forever. They, too, are going to eventually decay. But the timescale for their disappearance, that's where our human brains really start to struggle. This number is called a googol. It's a 1 followed by 100 zeros. This is roughly how long it's going to take for the very last, most massive black holes to just evaporate away. It happens through a bizarre process called Hawking radiation, which is this faint glow of particles that slowly, and I mean slowly, bleeds a black hole's energy back out into the universe. And just to try and give that number some perspective, get this. If you wanted to physically write this number down digit by digit, you would need more atoms than exist in our entire observable universe, just to have enough ink to do it. It's a length of time so vast that it's fundamentally beyond our ability to comprehend. After that last black hole finally fizzles out, the story of our universe reaches its very last page. We enter the final era, and from this one, there's no coming back. This is it. Heat death. At this point, all matter has decayed into this thin, cold soup of particles and radiation, and it's all at the exact same temperature, just a tiny fraction of a degree above absolute zero. And with no temperature difference anywhere, no energy can flow. And if energy can't flow, well, nothing can happen. Ever again. And look, this isn't just speculation, it's a direct consequence of the laws of thermodynamics. The universe began in a state of really low entropy, super organized, and it has been moving toward disorder ever since. Heat death is simply the end of that road, the final, ultimate state of maximum disorder. And here is maybe the most profound consequence of all. In this final state, the universe is static, unchanging, permanent. And think about this. If nothing ever changes, does time even exist anymore? The arrow of time, which has driven everything forward for trillions of years, finally just stops. Nothing happens, and then it keeps not happening forever. I know it's a pretty bleak picture, isn't it? An eternity of cold, empty, unchanging darkness. So let's just pull back for a second and ask the really big question. Seriously, if everything we do, everything humanity has ever built or created or dreamed of is destined to be completely erased without a single trace, what's the point? Does our tiny little moment of life have any meaning at all in a universe that is doomed to die? Perhaps the answer is right here. For one brief, dazzling instant in all of infinite time, on this one tiny speck of dust, the universe managed to produce something that could look back at it. Something that could study the stars, understand the laws of physics, and piece together the story of its own origin and its own ultimate fate. So, maybe our significance doesn't come from being permanent. Maybe it comes from the sheer improbable fact that we are here at all, in this temporary age of light. The very same stellar processes that will one day lead to the universe's death are also what created the elements that make us. We are the universe made conscious of itself, a fleeting but beautiful byproduct of a cosmos that's always changing. And the fact that we can even comprehend our own cosmic insignificance, well, that might just be the most significant thing in the entire universe.